microbit or maybe even the logo or other variations of block-based coding, using code.org or Tinker. And the goal of the session today is to help people who maybe have questions or who want to experience a transition from block-based coding to text-based coding. And today I'm going to share just briefly a little bit about how to start that with HTML and CSS. Because it would take a lot of other sessions and much more learning for us to dive into more complicated programming languages like Python or JavaScript. So I just want to thank everyone for being here today. And this is also being recorded and live streamed out onto YouTube and other social media channels. So if you're not able to see it live, the follow-up recorded session will be available. I'm going to go ahead and share my screen and get started with the session for today. One sec. There we go. Yeah, so Beyond Blocks is the name and the title of the session for today. And it's kind of a clever way to describe, what we're getting at here today. And just for those of you that haven't been a part of our webinars before, this is a 45-minute webinar, and it's meant to be a little bit interactive. We've got some questions that we'll ask you, and then we'll also have time for Q&A at the end of the session. But the things we'll talk about today is I'll describe just a little bit about BSD. We'll talk about where to start your journey with coding, if you're coming from blocks or Scratch or whatever. Then I'm going to share 3 strategies that you can use to transition to text-based coding. And then at the end, we'll share some sample projects from BSD and provide time for you to ask questions or to chat. My name is Mark, and I'm the Vice President of Education at BSD. I currently oversee curriculum development and the pedagogical process that we use at BSD and the professional development, including these webinars that we do. And I'm also a PhD student at Chiang Mai University in Thailand, which is where I'm coming to you from. And I'm studying artificial intelligence and how students relate to that, sometimes with coding and sometimes without coding, but maybe a topic for another session. And I've actually, if you look back in the previous webinars that we've done at BSD, I've done a session about some of the artificial intelligence research that we've collaborated on with BSD. So those of you that are not familiar with BSD, we're an education technology company, and we provide a variety of resources for teachers to help them teach digital skills, coding, and programming, all kind of wrapped up together nicely by providing teachers with access to curriculum, a platform to teach that curriculum on, training and support to guide the teacher along that journey so that students can have a real impact using project-based technologies and projects that have a real impact for student learning. I'll explain a little bit more about how that all looks towards the end of the session. But one of the core components of BSD is that we meld together these 3 different areas: hard skills, soft skills, and our values, which are curiosity, adaptability, resilience, and empathy, which we bring together under the umbrella of care. So if we think about the traditional hard skills, like actually learning how to program and code, and then soft skills of communication, collaboration, working together in projects, brought together with those values, creates unique learning opportunities for students. And we guide teachers through this whole experience of bringing together these 3 core elements. So about today's topic, where to start. What I want to do first is gather some information from all of you. If you're participating live, you can use your mobile device and scan this QR code, which will take you to a set of questions that I'm going to be asking. I've just got 2 questions, one now and then one later towards the end of the session. Or my colleague Beth, who's here on the call with me, she's going to place the link directly into the Zoom chat. So you can just click on the link if you're not using your mobile device to join. If you're watching this later, you can also see the results of the quiz or the question, and you can still contribute to it by accessing this link, wooclap.com/blocks2code. All right. I'm going to move on from that. So hopefully everyone got the link. If not, check the chat because you can still join on your computer, your laptop, your mobile device by clicking on the actual link. So the first question that I've asked is, what programming language do you plan to teach after blocks? So you've already taught blocks, you've already taught Scratch, you've already used code.org, you've used Tinker, Microbit, et cetera, some other version of block-based coding. And so the answers to these questions will help me to better understand where we are and where we're headed. So as the questions are being answered, I'm seeing a live update, and it looks like we've got a pretty even stretch with HTML, CSS, and then Python. And then others, of course, because there are dozens of other programming languages out there, it's hard to account for all of them. But you know, what we're seeing in the workforce and what we're seeing the need for computer programmers in the future is you know, a lot of HTML, CSS, JavaScript, and Python developers. So it would make sense that these would be the most commonly used and discussed. Now, today in the session, I'm going to be speaking more about HTML and CSS, but I'll be glad to answer questions about JavaScript and Python. I'm even going to give you some examples for JavaScript and Python so that you can start to take a look at those for yourself. So thanks for answering those questions. It's helpful for me as the presenter to get a feel for where we are. So one thing I do want to say is that, you know, there is sometimes some controversy in the world of programming where, you know, Scratch and block-based programming is seen as kind of a kiddie language, and it's not real programming, you know, if you talk to a real developer. But for me, I am the opposite. I celebrate blocks. I think blocks are a great starting point. It opens up a world of possibility. It gets students interested, and they also really do learn some important concepts that stretch across all programming languages. So all programming languages, you know, regardless of the syntax, are going to contain programming elements like loops, like variables, like event listeners. And then also block-based coding provides other you know, tangible concepts that relate to other fields of study. For example, if you're using Scratch, you have to learn about the X and Y coordinate plane, which then is reinforced in mathematics. It's reinforced in algebra. You know, if you're doing graphic design inside of Scratch, that relates to other technology skills, creating videos, creating animations. So Scratch and other block-based programming languages, I think, are a great starting point. And there's really no limit to what you can do inside of those. But when we talk about preparing students for, you know, workforce, for, you know, high school, then, you know, there aren't any developers in the real world who use Scratch to develop mobile apps or websites. So we've got to eventually transition to using real programming languages, and this is, you know, kind of you know, how we get started with that. So when I asked you earlier, you know, what language you're going to teach, that's probably the most important question to ask. But you may also want to be familiar yourself with some of these programming languages. So if you're a teacher and you know, you're helping students to transition to JavaScript or to Python, et cetera, you'll want to know a little bit yourself, right? So you'll want to have some experience yourself because, you know, just like any teacher who is a subject area expert, they have to know enough about that subject in order to teach it effectively. So if you don't know a programming language, you're going to want to spend some time learning that programming language. And later, I'll talk to you about how at BSD, we offer support for that. And we also offer courses for teachers about how to improve their own skill and ability in HTML, CSS, and JavaScript. But at BSD, we tend to only teach HTML, CSS, and JavaScript. Later, I'll talk to you about a Python course we're developing. But the reason why we have chosen HTML, CSS, and JavaScript is because these are the three languages that work together to display everything that you see on your browser. So whether you're on a laptop and you're using Chrome or Firefox, or if you're on your mobile device or your iPad or some other device, everything that's rendered on your screen through a browser is because of the coding that the browser reads in HTML, CSS, and JavaScript. So the question is, you know, what % of your day is spent on a browser? You know, for me, it's definitely more than a couple of hours a day that I spend on my job using a browser, interacting on the browser, and all of that is coded with HTML, CSS, and JavaScript. So that's why we think that these three languages are a powerful way to get students involved in programming. Now, it's not our stance that these are the only way or that they're the best way. We just think that it's a powerful way. So I do want to explain just a little bit more about these three languages if you're not familiar with them. So these three languages work together to display and to create the interactivity of what we see on the web. So I like to use the analogy of building a house. So if you're going to build a house, first thing you have to do is build the foundation and build the the structure for the house, the corner posts, the roofing, etc. So HTML is very similar to that. It provides the structure, it provides the content, it provides words and images. Then once the house has a foundation and the walls are up, then we can paint the walls. We can add decoration to it. We can do interior design. We can add color to it. So CSS is what does this to websites. It creates the color, the shape, the size, the positioning. So it kind of adds a bit of flavor to it. Then, if we want to have lights in our house, if we want the lights to turn off and on, and we want those things to happen, with switches or automatically, then we're going to need JavaScript. So JavaScript is a powerful scripting language, which allows us to create interactivity. And JavaScript is cool because it works in concert with HTML and CSS. So they all kind of work together. So, as a teacher, sometimes, especially if you come from any background of, language learning or language arts, you understand that learning a language is a difficult process, and learning to code is very similar to learning a language. And it would be really difficult and maybe a bit crazy for you to try to learn German, Spanish, and French all at the same time. So why would I ask you to learn HTML, CSS, and JavaScript all at the same time? Well, that's because by themselves, they have more of a limited capacity. So HTML by itself is limited. When you pair it with CSS, there's a wider variety of things you can do with it. When you add JavaScript, there's even more that you can do with it. So at BSD, we have a scaffolded approach where we start with HTML, we slowly layer in the CSS, then we sprinkle in some JavaScript. And then over time, we build up fluency in each of those. So it is a lot to try to take on the understanding of three different languages, but it can be done if done properly over time in a scaffolded environment. So today I'll talk to you and show you some examples using HTML and CSS. HTML and CSS are used in every single website that you view, whether it's on your browser, on your desktop, your laptop, your phone, or other device. So a little bit more about HTML. I mentioned earlier that it's kind of like the foundation or the bare essentials of a house. So if you think about the elements that are on a website, we've got text elements, images, links, buttons, and then the different sections of the website. This is all created using the HTML language, which builds the foundation and the structure for the website. Then when we want to adjust the size, adjust the position, change the color, have background elements, change the fonts, this is all done using CSS. So HTML and CSS work together really nicely for static web pages. So that means web pages that don't have much interactivity. We're not making games with HTML and CSS. We can make animations with CSS so they can look like it's interactive. But really, the power of JavaScript comes in later when we want to make things interactive. But it's a great way to start off with students, teaching them HTML and CSS for that basic function and foundation for website development, which then later can lead to game development, artificial intelligence, virtual reality, and other web-based architectures. So when you're on this journey of teaching kids to code and you're thinking about how can I get them past block-based coding, the first question you want to ask yourself is, what languages do I know as the teacher? And if the answer is 0 languages, I know no languages, then the next question you want to ask yourself is, how can I learn more? Or if I do know a language, how can I learn more about that language so that I can teach it to students? Then lastly, what curriculum is available for me to teach these languages? And there are a variety of providers of content and curriculum for how to teach coding. At BSD, we provide over 600 hours of coding curriculum that is brought together in a project-based environment with other digital skills. I'll explain more about that later and give you some examples. So what I'm going to do now is actually give you 3 strategies that you can use in the classroom for helping students to transition from block-based to text-based. And these are strategies that you can implement today if you wanted to. The first strategy is we're going to try live coding. So live coding is when you as the teacher open up a coding environment and you just start coding something. And what you're going to do is along the way, you're going to explain everything that you're coding, what it is, how it's working, and then let students ask questions. There are 2 ways to do live coding. One way is the students just observe you. They're just watching, they're just listening, they're just taking it all in. The other way is for students to actually follow along on their own computers. I'm going to give you that option today. So I'm about to do some live coding for all of you. And you can follow along and just listen to me and watch, or you can do the coding yourself by copying what I do, okay? So the way that we'll do this is I'm going to share with you a link, or actually Beth, my colleague, is going to share a link to a BSD sandbox. And so a sandbox is just a coding environment that allows you to type in HTML, CSS, and JavaScript code and render that code so you can see the effect of it, okay? So Beth, if you could drop that link out into the chat so that anyone who wants to participate can open up a new sandbox and follow along. So I've opened up a new sandbox here already. So this is the BSD online coding environment. If you're familiar with Scratch, you know, Scratch kind of has on the left-hand side the blocks and where you construct the blocks together. And then on the right-hand side, you have the outputs or the screen of what we're seeing. So our coding environment is very similar to that. So just to kind of navigate you around this coding environment, we've got the code here, the output here. There are 3 files across the top here. So we've got a file for the HTML, a file for the CSS, and a file for the JavaScript. Now, I'm not going to be doing any JavaScript today, so I'm going to leave that one open. We will add some code here and here. Now, currently, you see that there is a white box here, and the rest of this has kind of got a grayed out section. So what I'm going to do is I'm going to unlock the code. Down in the bottom left-hand corner, there's a little icon with a lock on it. I'm going to click on Unlock Code, and that will allow me to type into the code anywhere. All right. Now, BSD also does, we have some settings that we can do on the coding environment. So for example, I've got the font size a little bit larger. You may want to make it smaller. You can even change the color theme to a dark theme. So there's ways to modify the way that this looks. So what I want to do is just make a very simple web page. And so I live in Chiang Mai, Thailand. So what I'm going to do is I'm just going to make a simple web page that's about Chiang Mai and why I like it. So I'm just going to add some titles, some images, and some text. Then we'll use CSS to style that text and make it look good. All right, so this is the HTML elements for this web page. So it starts here at the top, telling me that this is HTML. In the header, this is information that is not viewed by the browser. So anything that's in the header is not shown. But what this is linking the style sheet, which is CSS. Then everything in the body is what you actually end up seeing on the screen here. So it says welcome to HTML because that's what's written here. But I'm about to change that now. So what I want to do now is add a title. So the way that we add titles is we use the heading element. So H1 is the biggest element, which will give me the biggest size of the title. So I've added the H1 element tags. And now in between those 2 tags, I'm going to give this page a title. And I'm going to give it the title of Chiang Mai, Thailand. Okay. So now if I hit run the code, I'll see the title is now displayed. All right. Next thing I want to do is actually add an image to this. So I'm going to hit a new line and I'm going to type in the image tag. And if you'll notice on BSD, as soon as you start to type in anything, I just start to type in IM, it automatically recommends, so it's kind of intuitive to tell me, hey, are you about to type in image source equals? Yeah, so now I'm going to just click that, and it automatically appears. And then my cursor is immediately placed where I need to add the link to that image. All right. So what I want to do is just come over to Wikipedia, and I find a free to use image of Chiang Mai. This is a temple during the Loy Krathong festival. So I'm going to open that image in a new tab so I can get the URL of that image. I'm going to copy that URL. I'm going to come back to my coding environment, and now I'm going to paste that in. Now, you can also upload an image. So BSD allows you, if you wanted to, there might be images that you've already uploaded, or you can upload a new image. So you can do either. You can add the link directly from the URL, or you can upload an image, your choice, okay? So now I've got the image. Let's run the code. We'll see that there's the image. Now, what I immediately notice is that this image is gigantic. It's so big. So later in CSS, we'll have to change the size of that. All right. So I've got a title, I've got an image. Next thing I want to do is maybe add a bit of paragraph text. So I'm going to just type in the word P, which is the tag that we need for paragraph. And then this is where I can add a paragraph of information. I can describe what it is that I like about Thailand, or what I like about Chiang Mai, for example. And so I'm just going to put a really quick sentence in here. I really enjoy the food, culture, and nature of Chiang Mai. So yeah, I mean, it's not a lot of text here. We could definitely add more later. So let's render the code, run the code, and now I can see that down here below the image, I've got the paragraph. So far my website's coming together. I've got a title, I've got an image, and I've got a paragraph. Pretty basic, but this is how we start to code in HTML. Now, some of you that code, will look at this code, and you might see that there are some discrepancies, or sometimes the alignment of where we put code. People can depending on the way you code, paragraphs could be indented or whatever. But at BSD, we have a handy little feature at the bottom here that's called tidy code. So if one of these was way over too far, the spacing doesn't really matter. But if I click on tidy code, it's going to clean up everything, and it's going to make it all aligned. But that's something for kind of like more advanced users. So now I want to come over to CSS, and I want to style my website. So first thing I want to do is address my heading 1. So I need to use a selector in CSS. So I'm just going to type in H1, which is the selector. There we go. And now inside the selector, I'm going to, let's change the font. So I'm going to just type in font, and then a font family is going to give me the property. Then the value, we've got some options here for different types of fonts, and you can add Google Fonts later if you want to have a much more, a wider variety of fonts. But let's just add monospace. So now let's check out the title. I've changed the font. Next thing we want to be able to do is maybe we center this. So I can change the font to text align. I'm going to use text align to change the font, and I'm going to change it just to center. So now run the code. There we go. So you can see immediately as this takes effect, my font is centered. Now let's address that image. That giant image is so big. So now I'm going to use the image selector. And well, when we're using CSS, we can also kind of change the layout of things, so where things appear. And so what I want to do is I'm going to use a CSS property called display, and I'm going to use the block value to keep it all in one block. Then I'm going to use the width, and I'm going to have the value. Actually, I'm going to change it to 100%. And so what this does when I use a value of 100%, is what that means is it uses 100% of the available width of the screen. So this actually makes it responsive. So if I look at this on a website or on a phone, it will automatically adjust the width to be 100% the width of whatever device I'm using. So now let's run the code, see what happens. All right, I want to change it to mobile. There it is, 100% width of the mobile screen, 100% width of this screen. If I was to make this full screen, it would be 100% width of my entire computer screen. All right. So yeah, let's see. Let's also change a little bit about the paragraph. So I'm going to use the selector for paragraph, and let's just change the fonts again and keep it similar. So we'll want to do font family, and earlier I used monospace, so let's keep it monospace, and then let's change the color. We can use hex values, or we can just type in colors. I can use brown. All right, so now let's run the code. We can see that now I've used CSS to change the heading 1 to have a different font and to be centered. I've changed the image to be in a block display with 100% width, and I've changed the font family for the paragraph to match the font family of the H1, and I've changed the color to brown just to give it some flavor. So now you can start to see, how CSS and HTML are related. So when I type in H1 here, that's the heading. When I use the selector for H1, everything that I put inside of that selector is going to affect the heading. Everything that I put inside the selector for image is going to affect that image. If I were to put other images in here, they would also all be with 100%. So if I wanted to single out one image, so maybe I wanted one image to be full width, another one to be half width, etc., then I would need to use IDs, which is kind of a more advanced topic that we can talk about in future sessions. But what I wanted to experience today is just, what does it feel like to do live coding? So whether you followed along or whether you were actually coding yourself, this process is actually very valuable for students to learn how to code, because they're experiencing it, they're hearing about it, they're learning about it, and they're being guided by you as the expert. So let me go back to my slides here. So yeah, the first strategy for helping students is live coding. And this is actually a research-based method. Researchers who study how children learn how to code have found that live coding is actually one of the best strategies. Another research-based strategy is syntax learning, which I'll talk about in a sec, but I forgot to mention another tool that you can use to help you with live coding is Microbit. So Beth, if you could put the link to this out in the chat. The Microbit coding environment, which is made by Microsoft, actually has a converter. So if you were to code using the block-based language, it would automatically convert that to JavaScript or to Python. And it's also vice versa. So if you were to type in Python or JavaScript, you could translate that to blocks. So this is the Microbit circuit board. Some of you may be familiar with that. And so there's just a simple program of the LEDs on the screen flashing, showing the heart icon, pause for 100 milliseconds, and then show the tiny heart icon. So it makes it give you the illusion of an animation. Here's what it looks like in JavaScript. So when you're doing live coding, this is also another strategy that you can do, where you're actually showing the blocks and the translation for what it looks like in the text-based language. But this only works for Microbit, for Lego Mindstorms, for other varieties of hardwares. There isn't a Scratch one or a website version that works like this. So you would have to kind of see which coding language you're teaching, which works best for you. So you don't want to use this to further confuse students. You would only want to use this if you have experience or students have already used Microbit, MakeCode, or similar languages. So like I mentioned, the other strategy that's research-based for teaching students how to code is called syntax learning. So syntax is the vocabulary of coding. So H1 is a syntax, IMG, SRC. that is a syntax, okay? And so the same way that we learn, vocabulary words, like for science, let's say you're a middle school science teacher and you have to teach, weathering, erosion, and deposition, which are, earth science terms. What you may do is, create vocabulary cards and use other variety of language learning or vocabulary building exercises. So the same ones that you would use to teach science vocabulary are the same ones that you can use for syntax learning. So I recommend vocabulary cards, which can be, printed out index cards or written index cards, or they could be digital index cards. At BSD, we even have a project called the Vocabulary Card Builder, where you make a series of these. You can also use a variety of different types of vocabulary games. I like to use bingo for vocabulary and fluency, so you can make a syntax bingo. If you're in a classroom where you've got wall space, you can use word walls where you put the word up on the wall and you have definitions, and you use the word wall in an interactive way where you point to the word every time you use it and you recall the word wall. But what all of these have in common is repetition. The more that we study the cards, the more the games that we play, the more we point to the words in the word wall, we're getting repetition so we can build fluency. So syntax learning, just like any language or vocabulary, is the same. So the same strategies that apply to English language learning or to other language learning applies to learning how to code. But a lot of people don't think about it like that. They think about it differently. So this is a handy way to also help students learn. At BSD, we have glossary cards that help with the syntax learning. So let me go back to the live sandbox that I was showing you earlier. So if there was a syntax that maybe I wasn't too familiar with, or if I needed some help with, I would just search for that syntax, and then I can open the glossary card. And the glossary card gives me several pages of information about that. So it tells me what it is. So I'm looking at the CSS syntax for padding. Padding is the amount of space around an element. An element could be a paragraph, it could be text, it could be an image. So we can add space around it so we can center it, or basically design the website in a unique way. It also tells me how to write the code for that, and it gives me examples. I can copy those and paste them directly into my project. And it usually gives me more than one way to do that. With padding, there are lots of different ways to add padding. So this glossary card tells me all the different ways. So this is part of a vocabulary building experience, okay? The next step that we might embark upon when teaching students how to code is tinkering. So tinkering is the art of playfully discovering and learning new things by trial and error, by figuring things out, by sometimes making mistakes and then figuring out how to solve those mistakes. And the reason why I put tinkering last on this list is because with text-based coding, it's not very easy to put tinkering first. I can't just hand students an environment and say, okay, tinker around until you figure something out. Now, Scratch is a little bit more intuitive, and you can start with tinkering. But I recommend that after students have had some level, then they can tinker. But one cool way that we can tinker with BSD is that our glossary cards actually have a built-in tinkering function. So let me show you that again. So here I am on the padding glossary card. The very last card on every BSD glossary card has a card called See It in Action, where I can actually adjust the code and see in a real time what happens to that. So here is a box that says Hello World, and it's got 10 pixels of padding. I can change that to 100. I can change it to 1,000. So it's updating as I see it happen, live in front of me. And then there's a few different examples. I can change each of these and tinker right inside of the code without it affecting my actual project. If I wanted to, then I could copy this and I could put it into my code, and there would be no problem. So we think that tinkering is a valuable way to help students after they have already had a little bit of experience. So there are the three different ways that we can help students transition to text-based coding, and these are all strategies that you can start with today. So now I want to ask the question. You can return back to the questionnaire that I shared earlier, or the link. So Beth, if you could put this back into the chat, because there are some people who came into the room after we started the first question. So the second question I'm asking all of you is, which of these activities are you most likely to try? So I demoed live coding. I talked a little bit about syntax learning and vocabulary building. And then lastly, I talked about tinkering. So as these things, as you answer the question, this will be updated live. If you're following along with the recording later on, you'll see the results of this and you can still contribute to that. But so far, the results that are coming in is we've got a majority of people who are willing to try live coding and some people willing to try tinkering. The numbers are changing. The live coding is the one that has the most impact. So live coding has the most impact on students, but it's also the one that requires you as the teacher to have the most skill. So you have to kind of be confident and comfortable and fluent with the language that you're teaching so that you can participate in the live coding. There are also lots of really great YouTube videos of live coding. So you can find, as a matter of fact, sometimes when I want to learn something, I go to a YouTube video and watch someone live code. My favorite live coder is Coding Train.
To this coding thing I signed up for.
I'm getting some feedback. Someone's got their microphone on. Please silence all, or Beth, if you could mute wherever that's coming from.
Let you know about the lane.
But yeah, like I was saying, Coding Train is my favorite live coding YouTube series. And I actually used it to teach myself some machine learning. So yeah, if you enjoyed these strategies, feel free to try them out, and we'd love to hear back from you about how they work. All right, so now I want to talk to you a little bit more about BSD and how we interweave all of these topics that I was telling you about and show you some example projects. So at BSD, all of our projects are put together with digital content as well as a coding experience. So one of our projects is called Personal Web Page, in which students are going to build a web page using HTML and CSS. And similar to the one that I was creating earlier, it's got a title, it's got images, it's got paragraphs, and we'll go into more detail with CSS about how to create sections and how to identify images separately. But alongside that, there's curriculum about digital citizenship, about privacy, about data privacy, because when students are building a personal web page, we want them to know what kind of information should go online and what information should we keep personal. So there are slides and there are activities that are meant to go along with in the classroom with the actual building of the website. That's just one example. Another example is the multi-page website, in which students are using HTML, CSS, and JavaScript to build a fully functioning website. And the curriculum that goes along with this project is that we want students to think about or actually find a community organization in their area or in their neighborhood where you can build a website for that organization. The example organization that we provide in the curriculum is a made-up animal sanctuary called the Kind Heart Animal Sanctuary. So students could just create a new version of this website for a make-up or a make-believe animal sanctuary or some other kind of community organization. Or you as the teacher can help the students connect to a community organization in your area that needs a new website, and then the students get to learn about that community organization and then build the website for that client. So at BSD, our curriculum is adaptive so that you can have a fully immersive experience like that, or you can recreate the examples that are already provided. Up to you and how you want to teach. So if you're interested in what we do at BSD and you like what we've seen so far, we have 3 different ways for you to interact with us. The first is through our free content. So we have a free trial in which you can use 7 free projects, or you can use the sandbox anytime you want to do live coding for free. We also have a program called BSD Teach, which is a monthly subscription where you as a teacher and up to 30 students can use some of our courses. Or if you want to implement BSD at a whole school level or a whole grade level, you can use all of our 600 plus hours of certified curriculum, which comes along with professional development, coaching, and live support anytime that you need help or you get stuck. So most of you will probably be most interested in our free content, which includes several really cool projects from very beginning projects. The easiest project is called The People Who Inspire Me, which you're just using similar to what I showed you today, HTML and CSS to build a static web page, all the way up to using artificial intelligence and a webcam image classifier to detect facial recognition or whatever you choose. So we have a lot of really cool free content. And then from there, you can choose to join us at whatever level you may be interested in. We do like to hear from you. So if you have any feedback on this particular session, or if you want to give us feedback about what kind of content you want to hear from us in the future, please let us know. My colleague Beth is going to put the link for this feedback form. And also, Beth, if you could just put the link to our website, bsd.education, so people can see where to access our free trial, our BSD Teach platform, or more information about how to get involved with BSD on a whole school level. Lastly, I just want to see if there are any questions from the audience and give you time to reflect or to chat. So I'm going to stop sharing my screen and go to my camera. Beth, can you let me know if there were any questions or any comments?
We do have a couple of questions to start with. The first question is, does BSD Education offer any Python content?
Good question. So we haven't had any Python content up until recently. We decided to create an introduction to Python course. And so one thing that's different about Python is that Python doesn't really have a visual element to it. Now, there are libraries that you can install that bring about visual elements for it. But most Python used in the real world is kind of a what we call a back-end language. So it's a language that sits on the server side, and we use it for queries. We use it for database management, et cetera. But we do, and we will this summer, have a course that teaches the basics and the fundamentals of Python syntax, which includes a few projects where you're going to build a secret language coder, encoder. Another project is like a time and date application. So it's more focused on traditional computer science concepts, whereas our content with HTML, CSS, and JavaScript is extremely visual and interactive, which we have found to be more stimulating for students because they actually get to see the tangible results of what they make, which is why block-based coding in Scratch is so popular.
Another question from Jan. Do you have any experience or feedback with your curriculum being used in MYP environment?
Great question, Jen. So there are several IB schools that are using the MYP that have used our projects, and the way that our curriculum is designed is that you can kind of pick and choose any of the projects. And we do have a curriculum that's on a continuum where you kind of start at lesson 1 and go to lesson 2 and so on, all the way through 40 or more plus hours. But in the MYP, if you're doing a specific project, let's say around design thinking, you could pull out the multi-page website project and have students build a customized version of that. We also, in the MYP, there's an element where students are designing games. So we have a whole video game design curriculum in which students build their own video games. We have a virtual reality curriculum in which students build their own immersive virtual reality environments. So it depends on how you use the curriculum. You may not follow the whole 40-hour sequence, but you can pick the projects that you want that most fit into the MYP. Yeah.
We have another question. Does BSD offer more advanced coding language course for teachers to learn HTML, CSS, and JavaScript and get a teaching certificate?
Yeah, that's a great question. So teachers who sign up for our BSD Teach or for schools who sign up for our BSD Build platform, automatically includes some professional development. We have a course called BSD Fundamentals and a course called Coding Fundamentals, in which we teach teachers in a self-paced online course the basics that they need for fluency in HTML, CSS, and JavaScript, so that they're very prepared to teach all of our courses, leading all the way up through virtual reality, artificial intelligence, and video game design. So it's a whole onboarding process that we provide to teachers and to schools who are using our curriculum in the classrooms.
And what should teachers do to keep the class more interactive with students at different levels of acquisition?
Well, the live coding, I think, is a really great way to have students, follow along and be interactive. And so, I mentioned that there are two ways to do it. One is to just the students are just watching you, but that's the least interactive. What you really want them to be doing is to have their own window open, and then they're following along with you. And then what eventually happens is students start to, they start to get familiar with the syntax and the process and how, CSS and HTML are related. And then you'll start to see them tinkering on their own. And that's where the real learning process starts to happen, is when they're kind of like the training wheels are off, so to speak, and they're kind of doing it on their own.
Okay, we have one more question.
Mm-hmm.
Is coding and programming only for technology teachers?
So, traditionally, we might think that coding and programming only involves in the areas placed in the IT classroom or the technology classroom or the DT classroom. But, if we think about digital citizenship and digital literacy, those things span across all subject areas. So coding and programming can be placed inside of every subject if it's brought together with the right context. So, for example, in social studies class, when we learn about societies, we may want to build, like in my example, a community organization. And so students are learning social studies, they're learning computing, they're learning programming, they're learning website building, they're learning communication, collaboration. So that's why I mentioned at the beginning at BSD, we bring together hard skills, soft skills, and our care values all together in unique projects that just also happen to include, programming in HTML, CSS, and JavaScript. And then I saw in the chat, someone was asking me about the name of my favorite live coding YouTuber. I put it in the chat. It's called Coding Train, like choo choo train. Coding Train. And then I got a question coming in. Can BSD's content link to any competition? So we do have occasional coding competitions for our partners. So schools that sign up for the BSD Build can participate in annual coding competitions. We're running one right now in Thailand, and the competition is about building a website related to the theme of Earth Day. So and students are taking a course. So they're learning how to build websites with HTML, CSS, and JavaScript first. Then they participate in the coding competition, in which they have to build a website from scratch using the sandbox. So yeah, we can help schools to do competitions. It's not international. It's case by case for every school that wants to participate.
Mark, we have another question. After students learn HTML, CSS, and JavaScript, what will be the next coding languages that teachers need to teach them?
So HTML and CSS and JavaScript build a wide base, and if you know those three languages, you can go out and get a job as a web developer, fresh out of high school, and we've seen students who do this. So I think going beyond that really is kind of the nuance of what you want to teach. So inside the world of JavaScript, there are other libraries or subcontexts like jQuery, and these are just ways to make the JavaScript easier. And so you can go into React, which are more lean ways to build websites, and that really puts people on a path for job placement or for maybe even into college, etc. But after you learn HTML, CSS, and JavaScript, the foundation and what you learn from there is going to help you learn any other language very quickly. So developers who know those 3 languages can easily pick up Python. They can pick up PHP, which are other, web-related languages. So I don't know if that really answers the question, because there's not like a right or wrong answer to that, but there are certainly lots of pathways to go on beyond that. Any other questions, Beth?
None from my end.
All right, me either. Oh wait, one just popped up. Do you have any stories about students learning BSD courses to help communities? Yeah, so the project that I mentioned earlier about the where students build a multi-page website, they can connect with their local communities to build websites based around that community's needs. I'm trying to think of a specific example. Not one isn't coming to mind, but I think that would be a cool thing for our marketing team to do, would be to interview a teacher and students and make a video about that we can eventually share on our social media and YouTube. So Beth, maybe we chat about something we can pull together for that later. Yeah, so that's all the questions, and it's also the end of the time for this webinar. We've actually gone over a few minutes, but I want to thank you all for joining. And please do stay tuned, because we have a webinar every month for the rest of the year on a different topic. And I'll be presenting in the Asia Pacific time zones. And then my colleague in the US, Allison, will be presenting in the North American time zones. So feel free to share with your colleagues and friends all over the world. And I hope to see you next time. Cheers.